Alluxio. He'll be presenting unified data analytics and AI. So go ahead and begin speaking. Thank you.
Yeah. Okay. Thank you so much. Thank you for the intro. My name is Ben. This is my colleague Xiuwei. We are from Alluxio. We're in Summertel, and today I'm presenting the work we're doing here as an open source project, open source technology. The project we're building is called Alluxio. It's the same as the company name is called Alluxio, and the mission for this project is to unify different data analytics and the machine learning workloads in the cloud especially for data applications, for data intensive applications. Okay. A little bit intro about myself. I'm the founding engineer and right now the VP of open source at Alluxio, participating Alluxio open source projects, and also I'm also participating other open source projects like Presto. And my email, previously I got my PhD in computer science from Carnegie Mellon. Xiuwei?
Yeah, this is Xiuwei, and I'm the core maintainer at Alluxio, and I'm also the open source community product management. And otherwise, I get my PhD from the Carnegie Mellon University before I joined Alluxio.
A little bit about the project we're doing. It's an open source project started in UC Berkeley AMP lab back in 2014. And in the beginning, it was actually, you can think this is a sister project for Apache Spark, if you've heard about Spark before, which is very popular for data scientists and for data engineering. And we have been open source since the very beginning. Although previously the name is called Taikiang, we rebranded the project to Alluxio I think in 2016. Today, we have more than 1,200 contributors on GitHub, and the number is still fast growing. We have 9,000 Slack community members asking us questions or providing us feedback. And I and Xiuwei are both very active on the Slack. You can see the Slack link here. There's a survey before, and it was listed as the 10 most critical Java-based open source projects on GitHub, and we have a lot of downloads. This number is actually very outdated. Okay, so this is the motivating slide. So essentially, as a data scientist or as an application users for data, we actually seeing there's observations. We have been talking to this different users of the data, and these are the feedback to us. They're saying, okay, we're seeing the data platform is getting more and more complex today, especially due to the popularity of the public cloud providers, cloud vendors. And these are great tools, great platforms, they are great services they are adding to the users. However, this is also getting more or rich sets of different choices, especially for a large enterprise. More and more, they're seeing the data is created more daily on a daily basis because everyone is trying to, all the companies in industry is trying to be more data driven, like building insights, deriving insights from data. This is how successful you see from Google or from Facebook, from other internet companies, and now the entire industry is following up on the trend. However, this also creates a lot of challenges, especially for a little bit like on the enterprise side. They have a lot of we call the data silos. They're creating a lot of different data, but often resulting in different services or in different places. We call them data silos. And this is because legacy reason, because organizational gap or difference, or also because of merger and acquisition into the bigger group or bigger company. So as a data engineer, a lot of people are actually busy, quite busy. They're kept busy to copy data from one location to another. And this is, some people call this ETL, or synchronizing data from in one source to the destination. So this is first slow, and second, sometimes can be human intensive and error prone. So that creates adding a lot of complexity in dealing with data in different data silos. And also we see a lot of more people and products are deriving insights or business insights from the data, which means they're using their tools to deal with data. And for the pioneers in the big data space, people are using more like Apache Spark or using MapReduce or Hive, this type of big data analytics tools, or interactive queries like Presto or Trino. You can think these are the SQL engines for big data, for OLAP workloads to derive data. But more and more new workloads are emerging. For example, we are seeing a lot of like machine learning workloads. They are using mostly like TensorFlow or PyTorch, or sometimes a lot of companies are using their homegrown tools to access data. And also data APIs is making a lot of progress in evolution. For example, in the 10 years back, the industry de facto way to access a large amount of data is perhaps using what is called Hadoop distributed file system interface. And nowadays, if you talk to people tell you S3 becomes a new API. S3 is becoming the new industry standard. That means you may see a lot of different tools built in different time. They're trying to access data, and you have to provide them the flexibility and the convenience to access the same data. Last point is about we are seeing a lot of innovation in our industry, especially building new computation framework or building new storage services. And this technology trend is going to be there's new innovation in the trend every 3 to 8 years. And that means a lot of providers, they're doing this, they're actively adopting this new technology. And as a user, you may see a different technology built in the on-premise time era, or hybrid, or they're looking for hybrid cloud because they have different resource in different locations, or multi-cloud because they want to keep the negotiation power with the public cloud vendors. So essentially what I'm saying here is there's a lot of different environments because the innovation trends, there's a lot of different environments or a mixed or different environments. So that makes the data engineering or data processing even harder. You have to cope with the difference, the gap in different environments. So here is actually, I want to show a very typical data journey for a lot of different corporations we've seen. Look at this part first on your left bottom side. This is a very typical way to access a big amount of data at scale in about 10 years back using Hadoop ecosystem tools in Hadoop ecosystem like Hive, Spark, or Presto to access HDFS. And this is within the box representing a data center in the one region. And later on, people are saying, oh yeah, I want to handle data in more different ways, consuming data in more different ways, especially a typical example is people are trying to get a different way to store the data or using PyTorch or TensorFlow to run their machine learning training workloads, so that this is a different, or this can become a satellite data center, or this is even a remote data center across the continent. And later on, the cloud provider is kicking in and they're saying, oh, yeah, you can use our in-cloud resource and you can run EMR, which is the Hadoop equivalent in the AWS, or you can use SageMaker, or you can use EKS for Kubernetes, and using our storage service like S3 and Google or Azure, they all have similar competing or equivalent services. That means you get a different choices. You have a lot of choices in your bag right now, and making this simplified is very hard because you just have a lot of different pieces to put them together. Okay, so essentially we're looking for a lot of people we're talking to, they're saying, hey, we really want the simplification back. And that really drives the market, we call this the market demand for simplification. So put this first is a unification. They're looking for a unification of data lakes. And there are a lot of different analytics and AI, and we want to provide a similar API and a similar or shared user experience across different stacks. So if you are able to process the data and you can run your applications in using one vertical or one data vertical, it's likely you can just extend your experience to the next. Like you don't have to learn a lot of new things. We call this unification of data lakes. And also because different teams, they have their own way to have this accessing data from different silos or the data in different formats, how to efficiently manage data and provide data applications very efficient way or consistent performance becomes also a very strong demands from users. We will see later, we will talk about the user use case study from Expedia, how they handle the data access. Like the data scientists are building a virtual data lake. And in this data lake, some data is really stored locally, relatively local. Some data is really in the remote region. And how do you unify the view from the user perspective? And data scientists have very consistent view to access the data. Lastly, is about providing a agnostic from different environments, so the applications can run without really knowing the details, and just application developers can write this in using some abstraction, like a very popular tools or abstractions. For example, for resource or for workloads is in containerization technology or in Kubernetes technology. Like using these ways, you can move your computation pretty much like seamlessly across different providers or different environments, because they provide a very good abstraction for your data applications. Yeah, they're just dealing with the same Kubernetes cluster, same standard, but in different cloud providers or in the data warehouse. And we're doing similarly, like how we can do this for the data. You don't need to deal with the difference in I'm dealing with data in S3, or I'm dealing with data in GCS. No, you don't have to worry about the difference. You just need to focus on building your application logic. I'm writing my SQL queries. I'm writing my training logic. I'm training the model without really concerning, oh, actually, I'm running this on GCS, or I'm on GCP. I'm running this on AWS. So I need to change the data differently. And some data is even remote. So you don't need to worry about it. So that's why we're building this, we call it Alluxio. This is open source technology to unify the analytics and AI in the hybrid and multi-cloud. And this open source technology is, you can think it's a new layer in the data stack. On the upper layer, it's about big data analytics frameworks, Spark, Presto, TensorFlow, or Hive, Hadoop. And we call this southbound. There are different choices in the storage, like S3 or Azure storage, different things. And we're providing a layer, inserting this layer in the middle of this data stack. And applications are talking to our layer as a data access layer or data abstraction layer. And we're translating the data access or the namespace into the storage, the service you're interested in. And this is a very flexible way to port your applications, your stack into different clouds, or using different services, or even merging them together. So let's go to the previous journey figure we're talking about. And we're trying to just say, okay, how about just using this layer, this open source technology can bring you a layer to unify the difference about different storage, and making this applications accessing the data in a unified way without worrying, oh, I'm really talking to S3, I'm talking to Hadoop HDFS, or I'm talking to another S3 equivalent on-premise deployment. So in this way, we build a foundation for the heterogeneous data platform across geos, and provides agnosticity to different computation engines. And there you can see a very long list of different vendors or different users in different sectors, including e-commerce or internet or financial. They're using this technology. And we're actually, for example, we are a partner with AWS. This is, they're talking about the modern data architecture. They can use this approach to build a data abstraction layer for the users. Okay, so I want to show you some examples, and show we can just walk you through a real user example. Like, especially for this talk, we want to emphasize on what's the problem as a user, as a data scientist see, and what's the drawback for different solutions, and how we can building this layer to solve this problem for data scientists.
Yeah, thank you, Bing. And in the following session, we will go through what is the real use cases in the Expedia and what they are trying to build for the data scientist. Actually, Expedia is like a traveling group which acquire a lot of different company like hotels.com, like VRBO, all this kind of company, and it's create a lot of problem for their data management. We call the data siloed for these different brands, because just imagine like you are working in the Expedia as a data scientist, and maybe your job is responsible for dealing with the data from the hotel.com. Another data scientist from another organization is responsible for dealing the data from the Expedia.com. So that means like when you want to analyze your data together, you have to do a lot of cooperation and move the data from maybe from the hotel.com to the Expedia.com to do all this kind of data analytics. It's caused so many inconvenience for the data science daily work, and you have to do a lot of across organization cooperation to finish all this kind of work. So actually they come up with the idea to say, hey, because there are a lot of problems there, so how about let's build a central analytic data lake with across the whole company instead of like we just work for the different brands. So actually they can come up with the idea called like a unified data lake. But actually there are so many problems you have to solve. The first of all, because all this kind of data can stored geo-distributed, which means like it can stored in the AWS US East Coast, it also can store in the West Coast, which is not feasible for you to like access data from the regional data center, which is cost so much money to like transfer the data across the whole US. And another one is like there also cause a lot of problems. You have to do a lot of manually maintenance for this kind of data copy. And which means like when you want to do the data analytics at the US East Coast, you have to copy the data from the West Coast to the East Coast to do the ingestion. So after that, actually they come up with the first solution called the replication to solve this problem. And we will this is how they build their solution called data replication. Just imagine like you are working at US East 1 with the Expedia at Seattle, and at US West 1, there's some office for the hotel.com. So with the current organization, you have to copy the data from the hotel.com to the US East 1 Expedia.group. Then you can access into the US East 1 region, I mean all the EC2 and the EKS, all this kind of computing resource at Seattle to do all this kind of computation. What kind of result you will get is like, because you do the data replication, it will cause a lot of latency because of data movement. First of all, you have to copy the data from the West 1 to the East 1. Then you have to do all the data validation, and you have to be aware of that this data is ready for me to do the consumption. So that means for your daily work, you just copy the data from the West to the East. And after that is ready, you can do all your data analytics to serve your business goal. It can take at least several of hours and even like a whole day to do all this kind of replication. It's just think about it. It's caused so many inconvenience for your daily work. And another problem for this architecture is actually they use one system called CircleString to do the data replication. And when you move the data, for example, from the US West 2 to the US East 1, from the data lake D and C to the data lake A and B, that means you have to do a new task for the data replication for any of your business purpose. For example, you want to query the table A, and also you want to query the table B. So that means for table A, you have to initiate a task to do all this kind of replication. And for table B, you also have to do it. So after that, actually, they think about, oh, it's not feasible for me, at least, like, and also cause a very bad user experience to data scientists to say like, I have to do all this kind of thing to do the centralized data analytics. So they think about how about like that? We just use Alluxio to do the centric like data analytics, which means that you don't need to do the data replication ad hoc. So you are just like have a Alluxio data lake at the main region, you want to do the data analytics and mount all this kind of different S3 bucket from a different region to the main region of the Alluxio. So that means when you want to query the data from the different region, you don't need to initialize here CircleString job anymore. You just query from the Hive, Spark, Train, or Databricks runtime anytime you want, and Alluxio will automatically catching the removed data to the local data like a main data region for you to consume the data. This is the overall architecture for how they implement the data orchestration for the Alluxio in the AWS. And actually, it's get three different benefits for them. The most important one is you don't need to do the manual work for all this kind of thing. And the second part, actually, you save almost half of money spending on the S3. And the third part is you don't need to do any manual work to add on any pipeline to do all this work. It saves a lot of time for your daily work to help you more focus on your business goal other than do all this kind of dirty work. And in order to achieve this, actually they do a query indirection here. And I will not go into detail it, but actually this query indirecting will help you to position where the data is from Alluxio or from the S3. Otherwise, I will give a really quick go through about Alluxio architecture. And actually, we are pretty cloud native architecture at this moment. And we have the Alluxio master for all this metadata operation, metadata store, and also for keep the data consistent to make sure you can get the latest data from across the region. And for the Alluxio worker, it performs the local performance to your application with the Alluxio client to speed up your data analytics applications. Underneath, actually, it will connect to the different we call the under file system like S3, Azure Blob, or any other storage you want to use. And with this data locality, actually, previous for S3, you have to access the data from the remote network. But actually, for our architecture, actually, most of the time you can access the local data, and which means when you do the data analytics, actually it will save a lot of time for you and help you to speed your data analytic jobs. And another way is another part is important of the metadata locality, which means we compared to you fetch the data from the remote AWS region, actually you can access all this kind of metadata from the same region as your application running. And I will not go detail into a deployment, but I want to spend a little bit time on the unified namespace. And for the unified namespace, just think about it. When you doing your job daily, and when you want to query data from the, for example, S3 region, and also you want to query data from the Azure blob, and also maybe you have some data from the on-premise with HDFS. You have to write a lot of code, for example, read the data from the HDFS, blah, blah, S3, blah, blah, Azure, blah, blah, and to get all this data. But nowadays, you only need to access the Alluxio schema, and you can discover all this kind of data across the region with a simply Alluxio file system tree instead of all this kind of different schemas. Yeah, this is all we have. And if you're interested in our project, please visit our website here. And you also can join our Slack here. And we are very active to answer questions there. And we also promote our events and all Alluxio information at the social media, at the Twitter and the LinkedIn. Any question?
First, thank you so much for the talk. It was very interesting. And now, yes, I would like to open up the floor for questions. So we'll start here, and you can speak. Please speak loudly. And when you hear the question, if you can repeat it, that would be fantastic.
Hi, team. I was wondering about the differences in latencies when you're doing an Alluxio stack versus a data replication stack. Because my question is specifically on how does Alluxio improve the latency in creating a replication layer which is far better than what an AWS kind of solution offers?
Yeah, this is a good question. The question is, with respect to latency, how Alluxio helps by creating this layer, this layer compared to using applications like accessing data directly. Yeah, it's a by the way, it's a great question. And the answer is it depends, actually. Yeah, it depends. So what we see is like a lot of times the public cloud vendor, public providers, they're working very actively and very aggressively to improve both the latency and the throughput for their data solutions. Like for example, S3 has been tremendous amounts of progress has been made by AWS to improve the service quality for S3, right? So like within the same cloud, like yes, there is latency improvement, but also depends on your data access pattern, whether you are reading repeatedly to the same set of data and whether you exceeding the API limitation or a throughput limitation on the services, S3 or HDFS, whatever you're using. But the one thing we notice a lot is when you are having this cross region scenario, the latency can be improved by a lot. So we have some white paper talking about you have the two different regions, one in the US, one is outside US, both on AWS, but running Spark. And we're seeing the performance gain due to the improved IO by 200% to 300%. So that is big improvement. But in addition to latency, in this scenario, there's a cross cloud or cross region, and cost is also another big factor, like as you mentioned, for the Expedia use case.
For Expedia hot data query, actually they save almost half of the cost when they are across with the replication compared to the across using the Alluxio.
Yeah, and also the reason is sometimes like, so see, all their data scientists submit their queries to this data region. This is their virtual data lake. There's this main data, they call this main data lake, right? And from time to time, it's touching the data outside this region because the data silo issue we talked about, they have data stored here or tables on different places. Just from time to time, you have things like this. If you just let the applications reading data in a raw way, you're ending up with repeatedly downloading data, and this is going to be killing your bill. Yeah, it's going to be very expensive. So that's why having a layer there as an abstraction to provide you performance consistency and cost reduction. So latency is one thing. I'm just go back to your question. Latency is one thing. It depends on how far your data is. The further is, the more performance improvement that we're providing. But in addition to that, people also taking a look at the cost as one of the major significant considering factor.
Thank you. Does anyone else have a question?
Hi, what is the biggest difference between your platform and other like data?
So the question is, what is the big difference between our platform and the other data platform? So in our space, I would say like we are perhaps the pioneer in this space, like building this virtual view, a virtual data platform across different physical, or like we call this persistent or physical data services. So I am not aware of any other open source projects doing similar, like a build for the similar purpose. So and partly because we are open sourced for almost more than 7 years. So like people are, I guess they have a lower motivation to build another one. Yeah, but there are other projects, like definitely there are similar or overlapping features in one way or another, but like building this virtual, sometimes I call this logical or virtual distributed system. So sorry, virtual distributed file system layer. I don't really know who else are doing this.
So my question has to do with, you mentioned that it's like logically or virtually stored. Does that mean that on read
Can you-
on read, or is it just?
Sorry, we cannot hear.
Can you, yeah, can you
Yeah, little
just be a
loud.
little louder? It's a very,
Can you hear me now?
yes, much better.
So my question is associated with how you mentioned that it's logically or virtually stored in your platform. When it is stored, do you get charged every time it's read when you want to access the data as it's making a call to S3 or wherever? Or is it just the one charge when it's logically stored? That makes sense.
Yeah, great question. So we have like a, oh, repeat question, but maybe you can try to repeat question.
Okay, is your question like asking if we're charging for the operation from the read and all this kind of metadata operations?
Yes.
So the yeah, so I want to clarify first, like we're talking about the open source project here, and we're not charging from the APIs or charging even from running these services. It's we have our enterprise edition, but that's charged by license. Like you have the yearly subscription. It's different. So the business model is different. But like go back to the cost model. I guess you are more asking the cost model for the users. So that's a very interesting question because that is very different. Like nowadays, if you run a application, you're as a data scientist, I'm running my queries, I'm running my jobs in the cloud versus 5 years ago, I'm data scientist within a data for this running some query, running some job within the corporation's data warehouse, right? The cost model is very different because nowadays it's taking AWS for example, if you list a bucket, they will charge you. If you download, if you are like, for example, issuing a lot of like API calls to a certain AWS service, there's from time to time, there's a limit, like they limit how much APIs you can issue per second. And also even for the amount of data you can fetch from AWS, typically it's enough if you are small, at a small scale. But if you're running at a very large scale, there's also a like a cap, like there's a cap. And sometimes it's within, from time to time, it's actually more like within optimizations within a black box, and you can hardly tell like what is the limit. So so the cost model is different, and versus previously, like in the data warehouse, you buy the devices, and from then on, you don't really pay. Like I don't pay more if I'm just listing a directory on my listing the directory on this in this cluster, right? So back to our story, as mentioned by Shouwei, we have two major components. One is the metadata service, one is the data service, right? So for the metadata service, if the metadata is not there for the first time, we have to get the metadata from S3 or from some other places into our metadata service. There's no black magic for us to know this data, know this file, right? You have to pay for that for sure. But after that, unless you're setting some further optimizations, otherwise the metadata is just serve the request from these applications. Let's go to the data side. For the data side, there is a capacity for how much data you are storing, right? If the data has been fetched into this data service and it resides there because it's hot enough, like our engine tells, oh, can tell this is a hot data and we don't move it around. Sure, now you just keep accessing this data without needing to go to other backend storage. But if the data is not hot enough and it was evicted by some other new workloads, and then next time you revisit the data, yes, you need to fetch the data again. And depends on where the data is. If it's within the same region, you don't have to pay for it, like taking AWS, for example. But if this is a cross region or from other data, from data cloud provider, then you have to pay for the egress data. So that's I guess I'm going to a little bit more details, but that's how complicated it is.
Thank you.
Yeah, so I have a couple of questions. So my first question is around security. Let's say organizations agree to have this as a middle layer. How is the security requirements handled? How are the security requirements handled?
Oh, okay. Actually,
Question.
I will repeat question. You are asking about how we guarantee the security across the S3 and to the upper layer of the computation. Is that correct?
Yes, yes.
Yes, actually, it's depend on what kind of component you are using. For example, if you are using AWS, most likely you will use like assume role, all this kind of thing from the AWS to do the request. Actually, if it's across from the S3 API to it, actually it will attach from the assume role from the AWS credential, and we will do the translation.
Actually, let's take one step back. So there is a built-in security model within this logical file system. Like files are directories, and files are associated with basic concept like owners and groups and security models like read, write, execution, this type of like security bits. So yes, these are already built into this layer, and we will check when you are accessing the data. We will check whether you have the enough permission to read this file or access this directory. So this is just a similar, very similar, like you are working with your own local file system or like a Hadoop file system, right? So that's the generic answer to the security model. But on S3, on AWS, there is some more specification. You can maybe continue to talk about it.
Yes, actually, we will respect for the different S3 and HDFS call. And if for S3, we will respect the assume role. And for the HDFS integration, we will respect what has been mentioned before, maybe the owner, or also we are also support the ranger, all this kind of support to respect the use query model you already used for this different underlying system.
Yeah. Just to let you know, like, by the way, this is a great question because we have seen this is one of the strongest requirements from all the users or customers. When they want to be very careful about the data. They don't want a random person being able to access their data because it's running in the cloud, and that's going to be very bad for them.
We're going to go on to another question. Thank you.
So I had a couple of questions regarding the ETL process via Alluxio. So one is that as of now, it seems that all the talk has been about fetch operations. Can we also do write operations? And second, when we do that, is the are there options to track changes in data and data lineage, etc.? So yeah.
Okay, so my understanding the question is, are we able to handle write operations?
Yes, plus are we? Yes, plus do we also track changes in data? So can we do we have version control over different
Version control. I see. Yeah. So short answer is yes. We are able to. So repeat the question. Like, are we able to handle write operations? Like right now, maybe in this presentation, we are mostly talking about as a read layer, read access layer for data. And can we handle write operations? And do we have version controls like that? So the short answer is yes, we can handle write operations. A little bit longer answer to that is there are different flavors you can configure your write to be. Like I want this write to be very persistent. Like I don't want to lose data. Then we provide the write mode to be like, you can think in other systems, they call this a double write. Both writing in the Alluxio space and also writing to your configured persistent storage layer like S3. The cost is it's going to be a little slower because you're just doing more work compared to just writing to S3, right? And there's other modes, like I'm just writing to Alluxio layer and it's dirty data, I don't care about it. And if it's lost, it's lost. And that's definitely be faster. And there's also a compromise in the between, like you can write into Alluxio space first and then come back, it goes back to your applications. And we will propagate this data into your persistent layer. And in a lot of systems, this is called write back, right? So we support that. And version control, no, we don't. Short answer is no, we don't have version control for that. And once you write, if you want to overwrite the same piece of data, you have to delete the data first, that piece of data first, and then rewrite it. Yeah, so it's gonna be just like a totally different file happening to have the same file name.
Thank you. Try speaking, and then my question is,
you're building a layer on the two sides. One side you have all the clouds, AWS S3, full cloud. The other side you have Apache Sparks, other applications. There are only so many things on both sides. At the same time, you have done most of it already. What are you going to do next as a company on a project? It's a project like
You want to answer?
You can.
Okay, the question is we're building a layer in between computation. There's a lot of different computation frameworks. Actually, let me go back to the slide. Like we call this northbound. Yeah, on the northbound, there is a list of different things. And on the southbound, there is a list of different storage. And as a company or as a project, like where we are going as the next. So the short answer is, okay, so this is my personal observation, my personal answer is, so building any, this is like what we're building as the distributed system. Building any distributed system is actually very hard, meaning you have to spend a lot of time to make it production ready and making it working well with different customer environments, especially nowadays we're dealing with a lot of different requirements, like dealing with containerized environment or bare metal and different security settings. So there's a lot of stuff around, even just to make it work well within the holy grail we're targeting, like the Spark, Presto, Trino, and S3 or Azure, Hadoop HDFS. Like there's enough stuff keep us busy just to make it work well. And like what keeps us busy, right? Because people want onboard more files. People want to onboard larger storage system services to this system, meaning we have to handle a larger number of files, or even larger files, larger individual files, right? All this is talking about in the distributed system world. This is called a scalability. How much data you can handle. This is called a scalability, and there are different ways to do this, different flavors. Doing this vertically, scale up this vertically, or scale out your system horizontally. Like on both directions, we're doing a lot of work there, and we're basically working in the space that by adding this layer, you're introducing new stuff, and new stuff may not be always consistent with the source of truth, which is your persistent storage. So, right. In that case, how do you make sure you have the data consistent? And there's no perfect answer to that. There's no perfect solution for that. It's all just about like trade-offs in the design. By the way, there's a lot of literature work in this, like how to make this distributed system running faster, running more scalably, and running more robust or highly available. So there's a lot of work there to keep us busy. But like on directional wise, this is one train, make this system itself the better. And the other train is really like, for example, the AI workloads I'm just talking about, it is still emerging workloads for us, like compared to the Spark or the traditional ETL, or not traditional, like at least a more familiar workloads like a Spark or Hive, this type of workloads. Machine learning AI workloads is even newer, and they're emphasizing on even more number of files. Recently, we're talking about one training job. This is from one internet giant. They told us they want to use us to handle their training jobs. The training job is consisting of 1 billion file, small images. Can you imagine that? Like that level of scalability, and also highly concurrent workloads. Concurrent workloads meaning they're running a GPU, many GPU machines. Each GPU is running many concurrent work at the same time. They're accessing data at the same time doing their training. So exercising on very different code paths compared to the ETL or analytics workloads. So that is also adding a lot of pressure or adding a lot of different nuance to the system design. So yeah, that's our actual next focus to handle the machine learning and AI workloads. And hopefully I answer your question. I know it's going to be a little bit more detailed into the details.
Very much. Okay, I have another question.
Hello. Hi, this what you've been describing sounds like a topic that I've read about on a really high level. I guess maybe you could tell me if I'm on the right track or not, but would you call this edge computing?
The question is maybe how to relate this to edge computing. I don't know if you have any insights.
The short answer is yes and no. Actually, we are not like put too many of our effort to the edge computing, but we do see like people build edge computing with us. But it's really depends on how you define the edge computing. If you define edge computing is like really like low power of the computing at the edge, and you can transfer the data back to your main data lake. Yes, we do it, and they can use our synchronization model to transfer the data from the on the file system. For example, you deploy some storage at the traffic light. For example, at Chicago, every traffic light they deploy the Kubernetes cluster, and they have some like a small self class there. Actually, we can do like help you to move all this of edge computing data back to, for example, back to the AWS3 to do all this computation. But actually, if we are talking about like we are responsible for doing some computation at the edge computing node, we are not doing that.
Yeah, so people have different understanding. Like this is still a context and relatively new to us. If we are, I know some people are talking about the IoT stuff, edge computing with IoT. I don't think we are. That's our target scenario. But we do see like we're actually collaborating with some other universities. They're talking about they have the astronomy data from Mexico, and they want to calculate the data like in different. Like a different scientists, they want to run certain applications in a unified way and on different satellites clusters. Yes, actually that's something we are working on this just right before this presentation.
Yes,
we're working with the scientists on these projects. They also call themselves edge computing, by the way.
Thank you.
So following up to the point about scalability, how do you handle the alerts and monitoring system because you're dealing with so many data? So
sorry, we
can you repeat it? It's a little bit vague here. And louder.
So is it better now?
Yeah, much better.
All right. So following up to your point about scalability, how do you maintain alerts and monitoring with respect to so much of data and different computing systems that you're maintaining? So for example, does this has an inbuilt monitoring system or alert system, or do you have to connect it with some other open source monitoring system like Grafana or Prometheus to maintain and check the computation, how much space it's getting, which worker node is being used?
So you mean like how we can integrate all this kind of monitoring system with Alluxio, is that correct?
And like, is it possible, or does this have an inbuilt monitoring system to make sure that the worker nodes are not failing, or there's enough space, or the computation different systems are also working in sync or in parallel?
Oh, you mean we also manage all this capacity, all this kind of thing, right?
Right.
Okay. Yeah. First for the
Repeat the question.
Oh, so the question is like, first of all, how Alluxio integrates the monitoring system, and second, the part is how Alluxio manage all this kind of hardware resource.
Yes.
Okay. The first question is actually we have a lot of metrics then you can expose to the Prometheus or Grafana, and actually it's very easy for you to build all this kind of monitoring through the Alluxio with your Grafana dashboard or Prometheus dashboard. And you just expose, for example, you can expose the metrics you read from the on the file system, and you serve with the Spark, Presto, or TensorFlow, all this kind of job. And you can see the dashboard from the Grafana, and you can see all this kind of information. And for the second part, how we manage the hardware resource, actually, it's a little bit different from the monitoring. Underneath, actually, you can set up, for example, for this worker, you only want to use like 1 terabyte of the capacity for your disk, then we will not exceed this kind of capacity. As a caching system, if we exceed this kind of capacity, we will invoke the all data based on your policy. For example, LRU, LFU, this kind of policy to make sure you have enough space for your use.
Just to comment on that. So essentially, this is whenever you build a distributed system, this is required. Like you have to watch closely how much resource you are using. Are we using more resource than the user or the admins wants us to use, right? So there will be when we're building this distributed system for each component, we need to have some mechanism to calculate, hey, for the disk space, are we using more than we should use? For the memory space, or maybe putting some alert in the logs, hey, are we using more heap memory than we should use? Actually, if this is a lot more than you should use, the process will be killed. And that's very bad for us, for our customers, users. They will see the service depends on its worker, master, or metadata, or the data site, and the service may just be stopped, right? So we need to be very careful about this resource utilization. And also for the there's an aggregation part on our metadata service. They also have a global view about, in total, the user is allocating, I don't know, 1 petabytes to this service, but now 800 terabytes is used. And then, yeah, this is through some mechanism, standard mechanism like a heartbeat, whenever you build a distributed system, this is a very standard way to communicate how much resource you're using, and are you in trouble, or you're in a healthy state, to a centralized controller.
Thank you. Do we have any more questions? I think that's it. Okay, go ahead.
Closer, can you closer and louder? Sorry.
I'm still confused how the service is going to improve the latency. Like, for example, originally I want to use Spark to access the Spark service. Like the service associated with the Spark, and now we have a middle layer, and how is this like improving the access speed?
I guess the question is
You
asking.
have explained this part, but could you just do it again?
May you just repeat your question again? I don't think I fully get it.
Because you mentioned that like adding the middle layer will make things easier and faster for the user, right?
I guess let me try to understand is your question like when you're running Spark, by adding this new layer underneath Spark, will the Spark job be faster? Is that your question?
Yeah.
Okay.
I'm a little confused about like this part.
Yeah. So the question, the answer to the question is, it depends. I don't think I want to claim like we're able to always speed up Spark or runtime. So in fact, there is a case, and there's actually a lot of cases you can see there's no speed up, or it's possible it's even slower. Depends on how you architect your system, right? If it's a Spark, like for example, in the early days, a lot of people are running Spark in HDFS on top of HDFS in the same data warehouse, and Spark is very smart to figure out the data locality on HDFS. They're trying to schedule, this is called a locality aware scheduling. The Spark scheduler is smart enough to put the Spark tasks to the executors with local data on HDFS. In that case, like I don't see there's any reason to put Alluxio in this case, because the data locality is well preserved, and it's from time to time, HDFS can leverage their system buffer cache to speed up. Yeah, so in that case, I would just tell users, no, there's no reason you put Alluxio there. And we see in cases like, for example, especially you have part of a data or a lot of the data in a different region, or in the like you're running this Spark job, but reading data. Like for example, we have one user, and they're running it's a hedge fund, they're running their data machine learning jobs, but they don't have their data in the cloud. They're running the jobs in the cloud, but they don't have the data on the cloud because they want to keep the data secret in their own data warehouse, right? So if the Spark job repeatedly go to the internet, go through the wire to fetch the data, then it's going to be slower. And it's going to be bottlenecked. because it's bursty. But in that case, some layer like Alluxio there will be very helpful. So actually, that's the reason they use Alluxio.
In addition, like some of the Spark job were very heavy in the computation. For example, you do a lot of joining and you do a lot of aggregation during your task. Maybe IO just like less than 5%. Actually, even you reduce the IO to the 0%, actually your workload didn't speed up a lot. So it's well depend on your architecture and also depend on your workloads.
It's like the service can keep the data for the user for a while. If the user is processing the data multiple times. Can I understand it like that?
Did you hear?
Yes, actually, we as a caching layer, we will keep the data for a while. Yeah.
On your service, like on your service, right?
Yeah, in our data service,
Yes,
yes.
data service.
Yeah. Okay. Thank you.
Thank you very much. Do we have any? Oh, we do. Do you want to try speaking and then I'll bring the mic?
Yeah, could you hear my question is like sometimes the company migrate or migration. So sometimes the data will only be available within the time of data scientist. But that may mean that your service will resolve this issue.
Is there anyone asking question?
Yeah, I think there's a question.
Sorry. Do you hear me now?
Yes.
Yeah, so sometimes the company is doing some data migration, like a GCP migration. And I just wondering like how, and sometimes this data won't be available for the data scientists due to the data migration. So just wondering like as your service encounter this kind of data migration, and sometimes it will take a long time period, will you solve this kind of issue because you have main data lake, or yeah, or how will you handle?
So let me repeat your question. Like during the data migration, maybe from on-premise to the cloud or from the one data center to another data center, this data is not available for the data scientist. And you want to see how we can solve this problem, right?
Yeah.
Oh, it's really a good question. And we saw a lot of use cases like people trying to migrate the data from the on-premise data center to the cloud, or from the one cloud to another cloud, or even like one on-premise data center to another on-premise data center. The old way people do it, like they will build a replication as Expedia did before. And when this data is ready in another data center, actually they can consume this kind of data. But if with Alluxio, actually we don't do this way. You can continuously move your data from one data center to another data center. At the background, you just make a copy, and at the same time, if you want to make data scientists immediately want to consume the legacy data from the old data center, you just deploy a Alluxio cluster in the new region or new data center, and just mount the old data from the old data center to the Alluxio cluster. Then you can just directly build your application, your data warehouse, your data analytics application, top on the Alluxio in the new data center. Then you can consume it directly. Even you write the data back to the old data center, we still will automatically keep it up to date. You don't need to worry about the out of data in the new data center.
Thank you. Do we have another question on this side? Thank you.
So my question is, like, how easy or difficult is it to put the Alluxio layer in a existing data architecture for a company? Does it come with a lot of plug and play components?
Sorry, can you repeat the question louder?
Yeah, how easy or difficult for a company is to put in the Alluxio layer in the existing data architecture?
Is it the question is it difficult for a company to integrate Alluxio into their existing stack? Well, I guess yes and no. It's a distributed system. It's always there's always an effort. Or like I don't know how many of you in our attendees has the real like the import production experience maintaining a service in production, like for even large workloads or birthday workloads. It's always a challenge there, like for any service. And so it's from that perspective, definitely you have to spend some efforts. And there's a lot of like resource contention, or there's just because of birthday workload or run configuration, or some components you're depending on the down, like the DNS service or Zookeeper service, all these type of issues. You see from time to time, it's not affecting only us, but also a lot of different components in production. So from that perspective, yes, it's definitely it's not that, in general, it's not easy. From another perspective, like whether from the integration perspective, like because it requires no change on the source code for the applications. So it's a pretty easy, like you don't have to recompile your application, you don't have to reconstruct your applications. And companies like for example, Expedia, they are even smart enough to figure out a way to, even without changing their data address, they hacked their catalog service. So the catalog service can tell, oh, if the data is in a different in a different region, pointing the address or redirecting the address to Alluxio. Otherwise, just directing this address to my local S3 region. So in that case, like they don't even need to change at all their applications. The data scientists or their data admins, they are just happily live the life as they're living before. Yeah. So I mean, yes, it's both. It has its part. We purposely make it easy, and just like the nature of being a distributed system, being a distributed service, it's never an easy journey. Hope I answered your question.
I have one question. I think kind of ties into a concept that we discussed in one of the slides. So in certain cases, we will be using Alluxio to kind of build a federated data warehouse where you want a layer between different independent data warehouses, probably in different regions.
Yep.
So my question is specific to a particular aspect of a federated data warehouse where, let's say, I want a particular data change in the Alluxio layer or the global data warehouse layer. Like, how do you kind of help to persist that to your local data warehouses? Because in a case where, let's say, I'm working in the western region of US, and let's say I'm one of the clients like Expedia, where I just do a data hack and use the local data warehouse instead of Alluxio layers. How does the federated data kind of persist down? Right? So there should be a downward flow aspect. Does Alluxio support that?
So let me try to repeat your question. So basically, when we're building a federated data warehouse, by the way, that's a good name. I really like the good term. I really like it. So sure, you should take a note. Yeah, federated data warehouse. And it's how do we persist the data if some user change a part of the Alluxio, like the data in Alluxio, right? That's is that your question?
Yes.
Yeah, so we have as I mentioned, like we can handle writes. If you have put some dirty data in Alluxio by changing the existing data, or you're writing a new data, like we can depending on the options you set for these writes, we can propagate this data to the corresponding physical address. So yes, we will do that. We have the downlink. Yeah.
Okay. Thank you.
Yeah, thank you very much. I think we will end there. Thank you, everybody, and please give them a big round of applause.
Yeah. Thank you for all the great questions. This is really very interactive and very educational to us too. Yeah, thank you a lot for attending.